momentum. We all have it, except for this guy. We've been building a component that only has momentum in a straight line. So while it's technically correct, there's a difference between being correct and feeling good. The real difference between these two movements is a change to how velocity is being modified, where one component treated certain applications to velocity as an on-off switch. The other component gives each velocity application a dedicated slot. So, accelerate runs before everything. It constantly adds velocity if it can. Since accelerate always accelerates uncontested, we need something to push against it. This is why we need decelerate to happen after all the movement has happened. It relies on mostly one variable, drop. And that's just how much speed we're cutting this frame. We take that off of our current speed and then we rebuild the velocity from there. Ironically, some might say that that contradicts the premise of never directly setting velocity, but the direction never changes. We're only shortening it. It grows and shrinks, but never actually snaps from one value to another. With these two in place, here and here, we can spend some time tuning our variables to our liking. Like, if you set acceleration and deceleration to be equal, they will balance each other out and you'll move at your target max speed. This is the core of the whole idea. But I'm not happy with how slow we turn, and there's the fact that at some point we can just rocket past our ideal speeds. If we wanted to start tackling some of these, we can start by adding another force to combat the mighty acceleration. Every frame, there's a gap between the way we're moving and the way you're asking to move. Friction just decides how much of that gap we're going to close. If it takes too little, then it takes longer to turn around. And if it takes a lot of it, then you can turn much faster. I'll admit, what I did here was a little hacky, but it was just to have an extra knob of control. But what you should actually do is decel times braking factor or something to control how quickly we stop when no input is being provided. That's it for the most part, but I definitely did not get inspired by Sonic the Hedgehog or anything.
I lied.
Apply slope momentum is always checking whether we're going up or down a slope, simply by using the dot product. And it takes that dot product, multiplies it by slope momentum to add or subtract more speed on a slope. So if we're going up the slope, it takes away speed. And if we're going down the slope, it adds speed. This gets us back into the situation where velocity can go crazy again. If you don't care, then leave it or tune it, whatever you want. But if you do, then we can introduce a new line to help deceleration fight against acceleration some more. If we are ever over max speed, we gather the excess amount and multiply that with a variable I called overspeed gain. The idea here is we're still not clamping anything, so you can go over, but you just can't keep creeping further from your target max speed. So the further you get from target max speed, the harder this will pull you back, just to try to maintain the balance. I also updated the jump method to borrow some of the slope direction logic from apply slope momentum. We just use the slope to influence what direction we're sending velocity. So as long as we're going down the slope, the steeper it is, the harder it launches us. And there you have it. I'm done adding stuff. For now.